All right, when we're doing the features on number 5, notice it's asking for domain, range, min, max, decreasing and increasing of the whole function, the whole piecewise. Notice there's several parts of this piecewise. We've got this constant part, we've got a negative linear function, we've got a positive quadratic function, and then this last piece could be looked at like an absolute value function or two linear pieces. But if we're just looking at it as piecewise here, it's literally 1, 2, 3, 4, 5 pieces. Even though there's going to be 5 pieces to the bottom piecewise function, so down here, we're going to have 5 different pieces. When I'm doing the whole domain features part at the top, it's going to be about the entire function. So I do also take note that right here, there's a gap in the domain, and right here, there's a gap in the domain, that the function stops and starts with a space in between. So when I go do this original starting domain, I'm going to say that the domain from left to right goes from negative infinity up to -8, and that's going to be open to open. Then it starts back up at -7, not included, and it goes all the way to 1, included. Then finally, it's going to start back up again at 2, included, and go forever in the right direction. So this is a 3-part domain because of those 2 gaps in between. The range goes all the way down and then up until a max of 10. Well, I like to do it in this order. I like to say that the minimum goes from negative infinity to the maximum of 10, so that when I have the min and the max already written out, my range is nice and easy because my range is the min to the max. And now that's done. The decreasing sections of the graph are anywhere where the slope is negative. So I've got a decreasing section from -9 to -8. I've got a decreasing section from -7 to -5. And I've got a last decreasing section from 6 to infinity. I put little U's in between this to mean union or and. My increasing sections go from -5 to 1 and from 2 to 6. Again, I'm going to put a little U for union in between those to mean and. If I had asked you for the constant section, the section that is constant goes from negative infinity to -9. Do you see that one as well? I use all open brackets on the intervals increasing, decreasing, and constant because we're talking about what's happening in between 2 points instead of at a specific point. Finally, I'm going to go through my 5 pieces of my piecewise function. I've got a constant function that goes through 8. I'm going to use the point -9, 8 for my linear function, and I see that the slope is down 1, 2, 3, 4, 5 over 1. And then I'm going to do a quadratic that starts at -5, 1. And goes out to up 1. 1 of the normal 4 is a 1/4 stretch. Then I've got a linear piece. I'm going to use the same central point of 6, 7. Let's check that. 6, 1, 2, 3, 4, 5, 6, 7. So I'm going to say x minus 6 plus 7, x minus 6 plus 7. I'm using the same point for both the upwards and downward sloping lines. And then in the first one, the slope is up 1, 2, 3, 4, 5 over 2. So the first one has a positive slope of 5/2, and then down 5 over 2 for the second one. Now I can get all of my domains ready by saying less than x equals, less than x equals, less than x equals, and I just need to plug in the beginning and end values. So the first piece goes from negative infinity until -9. The next one goes from -9 to -8, Next one goes from -7 to 1. Next one goes from 2 to 6. And the last one goes from 6 to infinity. Now let's go look for any inclusive points. For the constant, I'm going to begin this -9 as the inclusive point. The -9 cannot have a bar in both places, so I'm just going to include it in the bottom. Then it's open there, and it's closed here at 1. Then it's closed here at 2. And I can decide where to close it at 6. Do I want to close it here or here? It's your choice. So I closed it at the top. There it is, my 5-piece piecewise function with 5 domains and all of the features of the whole graph. What do you think?